Hi apes! Today we're going to be going over Unit 4, Part 1. Now I apologize, this is going to be a little bit choppy because we're going to be talking about all of our basic earth science concepts. So we'll be going into land, we'll be going into water, we'll be going into the atmosphere, so it might feel like we're jumping around a lot. So I want to start off with our oceans. So our oceans are one of the great climate regulators on our planet. So the thing that oceans do is they can absorb heat very well, and they'll transfer it around the globe. So if you take a look at this diagram down here, you see blue lines and you see red. So the blue is a cold, deep water current that travels around the globe, and when it hits the equator, it starts to absorb heat from the atmosphere, and it transfers heat around the globe. So over here, you can see this one right here is our Gulf Stream. So the Gulf Stream picks up heat energy from the lower tropics, and it transfers heat energy actually across the Atlantic Ocean, and it's a great climate regulator. Now, what drives these ocean currents is density differences. Cold water, salty water, that's more dense water, and that's going to be traveling deep and slow. And our warmer water is our surface water. So it's really density driven currents, but their main thing is they transfer heat around the globe. And because we do connect all of our oceans in one giant current, we do call that the global conveyor belt. Now, to bring in our land pieces, I do want to introduce a very important concept that's called a watershed. So a watershed, a good definition of a watershed is that it's an area of land that drains to a common body of water. So one key factor here is that all of the things that are going on the land are one of the most important things in a watershed. So when it rains on a hill, water is going to go downhill. And if it rains on the side of a mountain, if it lands on one edge of the peak, it's going to go in one direction, and if it lands on the other, it's going to go into this way. So when you have a river or a stream or a bay or even an ocean, you're going to be collecting water from a large expanse of space. And that water is runoff, and it runs off on the surface of the earth before it enters that water body. And it picks up pollution, it picks up sediment, it picks up whatever's on the land. So it's really important that we take into consideration what we're putting on our land, like fertilizers or pollutants or oils. You might have seen signs as you're driving around that you're entering or you're exiting the Chesapeake Bay watershed. This diagram over here on the right shows all the rivers that connect and eventually flow into the Chesapeake Bay. But the yellow is the actual watershed. It's that land that drains into those bodies of water. So anything you do on any stretch of this land across 6 states will make its way to our Chesapeake Bay. So the things that really impact a watershed are the slope, because that's going to determine which direction the water goes, the soil type, because that's going to impact whether or not water is absorbed into the soil or is more prone to run off, and the types of vegetation, because that's going to be helpful in anchoring soils and preventing erosion and preventing runoff. So now to get into our atmospheric structure. So again, these are just basic earth science concepts. So we need to take a look and understand that our atmosphere has layers. So you do need to know your layers of the atmosphere. We start down here at the bottom with the troposphere. And the troposphere is significant because this is where weather occurs. So all of our weather occurs in the troposphere. Later on in the year, we're also going to talk about global warming. That occurs in the troposphere. The greenhouse effect occurs in the troposphere. Most of our air pollution occurs in our troposphere. So those are all key concepts that we'll be talking about in the future that all are tied to our troposphere. The stratosphere is significant because of the ozone layer. So the ozone layer is found within our stratosphere, and that's significant because it helps to protect us from UV radiation. Again, that's going to be something we cover into the future. And the mesosphere is this layer in the middle, and then the thermosphere is the upper level. One significant thing about here is this is where the northern lights occur. Now, you don't have to know the heights. You don't have to memorize the altitude that these layers occur at. But I do want you to kind of understand why we have them separated the way we do. And we do that by temperature. So here, if I start on our surface of our Earth, then we'll go from cold to warm. Now, typically on the surface of the Earth, as you go in altitude, as you go up in altitude, you get colder. So if you climb high up a mountain, if you're flying high on a plane, it's going to be colder the further you go away from Earth. And this is because heat is radiated off of the surface of the Earth. Then you're going to get to a place where you have no change in temperature. We call that the tropopause. And then in the stratosphere, you're going to get warmer. Now, the reason why you get warmer in the stratosphere is because there's a lot of chemistry going on with those ozone reactions. And so there's lots of movement, there's lots of kinetic energy, and so that warms up the atmosphere. And then you again have a pause, we call that the stratopause. In the mesosphere, it gets colder. And then again you have a pause. And then in the thermosphere, again it gets warmer because the air is so thin up there. And so you see this predictable pattern of temperature changes, and so that's how we delineate where the levels of our atmosphere are. Now, weather that occurs down in our troposphere, weather is going to be our day-to-day temperature and precipitation. So this is how cold is it today? Do I need a jacket? Do I need my umbrella? So this is day-to-day. Now, climate is your long-term average temperature and precipitation. So there is a difference. So for instance, if we take a look at our weather in February in DC, that tends to be very, very cold. But that's not our climate. We are a temperate climate. And so it is important to understand that distinction between weather and climate. Now, a big thing that affects both weather and climate is how the sun hits the Earth. So a lot of that has to do with our angle of the sun hitting the Earth. That if you're at the equator, you get a more direct sunlight angle. So that means you're warm all the time. At the very northern regions, the sun hits at a very oblique angle, so it never is going to be very warm in our polar regions. And then you'll have your intermediate climates in between. So it is going to be important about how much energy you absorb from the sun. But other things that come into play that you may not think about are geologic features. One big one are mountains. So with mountains, you have something that's called the rain-shadow effect. So if you are air, and air is coming this way, air can't go through a mountain, can't go around it, so it's got to go up and over a mountain. Now we know in the troposphere, as air goes up in altitude, the air is going to cool. And when there's any moisture in the atmosphere, it's going to condense. And it's going to form clouds. So in the rain-shadow effect, you have clouds that form on what we refer to as the windward side of the mountain. So you have air approaching the mountain. The air has to rise to go up and over it, so it cools, condenses, and forms clouds. So you have rain on one side of a mountain. And by the time the air goes up and over that mountain, it's going to be dry. So on the leeward side of the mountain, you often have deserts. So you have two very different climates based on its relationship to that mountain as the air goes up and over it. So a lot of times you might have rainforests on one side of the mountain and deserts on the other. Now, another thing like we learned about in the first slide is that oceans are big climate regulators. So if you look at Northern Europe, they have the same latitude as Canada, so you might expect them to have a very similar climate to Canada, but they're much more temperate because the Gulf Stream has hooked around and brought some regulating heat that it gives off from the oceans. Now, another thing that affects it are cities. So cities, because you have a lot of pavement, you have a lot of industry, cities are always a little bit warmer than their rural counterparts. So if you take a look at a cross-section of temperature, rural areas tend to be a little bit cooler, and urban areas are always going to be a few degrees warmer because of all the industry and the pavement that absorb heat. So we call that the heat island effect. You're always going to have a little bit warmer temperatures in cities. Now, a lot of these things come together and affect our weather, but they also affect our climate. So there definitely are climate differences. And it is all tied, in essence, to the uneven heating of the surface of the Earth. Now, our Earth in space is actually tilted. Its axis is tilted with respect to the sun. So what happens is in the summertime, you're going to have the sun, the Earth will be tilted towards the sun. So here we'll make this our sun. So here in the northern hemisphere, you're going to be receiving more powerful sunlight than in the southern hemisphere. So that's why here this is summer in the northern hemisphere, but winter in the southern hemisphere. Summer in the northern, winter in the southern hemisphere. So it's actually the tilt of the Earth that gives us our seasons, not its location to the sun. Now, another thing that impacts our climate is the rotation of the Earth, and we're going to learn about the Coriolis effect in a second. But the Coriolis effect, the spinning and the rotation of the Earth, actually sets into stage our prevailing winds. So our prevailing winds will determine whether or not we're receiving storms. Often we'll have a dominant wind pattern that will dictate the weather that we occur. So our Coriolis effect is also tied to our climate. And that also, one thing that happens is our atmospheric convection currents. We'll see that. This is going to set the stage of whether or not you tend to be dry or wet. So here, you're going to be able to determine whether or not you tend to get a lot of rain, like in the tropics, or you tend to be dry, like in the deserts. And then again, our ocean currents are going to come into play. So I'm going to play this. So this is going to tie a lot of what we just talked about together about how the sun hits the Earth, and this sets in motion the climate and therefore weather that we see day to day.
The sun's rays are less spread out in equatorial regions than in higher latitude regions. At the equator, air near the Earth's surface is warmed, it expands, and it begins to rise. As the air rises and moves away from the equator, it cools. At about 30 degrees north or south, the air, now cooler and denser, sinks back to the Earth's surface. Some of the air flows back toward the equator, and some toward the poles.
So what you're seeing here now is a function of convection. So convection is essentially that heat rises. So when you have a lot of heat at our equator, because of the way the sun angle hits it, that causes that air to be less dense and it rises. It is deflected and up at altitude because we're in the troposphere. It cools, so it becomes more dense and it sinks.
At about 60 degrees, the air flowing toward the poles collides with cold air moving away from the poles. The collision of these two air currents forces air upward, where it moves toward the poles and back toward the mid-latitudes. This pattern of global air circulation gives rise to differences in rainfall at different latitudes. As air rises, it loses its capacity to hold moisture. As a result, rainfall is highest at latitudes where air rises and lowest at latitudes where it sinks. This is why rainforests are found at the equator, evergreen forests at or around 60 degrees north latitude, and deserts at around 30 degrees north and south latitude. Deciduous forests and grasslands thrive in areas with intermediate levels of rainfall. Thus, the uneven heating of the Earth by the sun sets in motion the Earth's global air circulation. This leads to latitudinal differences in heat and moisture, which determine the distribution of the Earth's biomes.
So if you remember, you took a look at our biomes in one of our earlier units, and they are not just placed around the globe willy-nilly. They're placed there because of the way that these cells circulate. Now we're going to be able to put names to these giant vertical circulating cells, and then we're also going to be able to translate these cells into why we see prevailing winds that we do across the globe.